Well, thank you very much for having me here today. And as an educator, a researcher, and a responder, let me assure you that innovation is game-changing. And what we want to talk about in particular is game-changing for disasters. And I want to go even one step further and talk about how robots, that innovation, is a particular game changer for disasters, that innovation. And when you think of robotics, when you think of disasters, you probably think of radios, better radios, our internet, our GPS. Maybe you weren't thinking of robots because you think of them as the Terminator or the Predators. But instead, what I'm thinking about are these small robots like this, ones that the Coast Guard, the fire rescue teams, the wildland firefighting can carry with them and use them. Low cost, easy to use. And you may not be aware that they've already been in use since 2001, 9/11. The first use of ground robots was at 9/11. They've been used since then in 47 disasters in 15 countries. Our team was at 9/11 and at 19 others of these disasters. So they're there, but they're not game-changing. Not yet, but they're an important innovation as they continue to improve and game-changing. So let's talk about how they can change the game. Well, if we're talking about changing the game, what is the game? So the disaster game, any game, you need to know how to keep score, you need to know the players, and you need to know the rules. So one way to think about the score is what the end looks like. Every year, there are 700 disasters, things that exceed local resources, that leaves over 1 million people dead and 2.5 people either injured, life-threatening, they're going to be crippled, they're going to have disabilities the rest of their lives, or they are never returning to their homes or their jobs. And we're looking at nearly close to $1 trillion in economic losses. So it's pretty easy to see the final score would be anything that helps you save lives, that helps you preserve the quality of life, and accelerates economic recovery. Well, that's kind of a final score. How can we do it like we do in other sports, where we break it down? So like baseball. Baseball breaks down the action and the score by inning. And it also helps you get the statistics on who's batting, who's doing well, and predict the future. In disasters, we use something similar. We don't have innings, but we have 4 phases. And those phases, the score is based on time. And there's a weighting associated with it. The faster you go in one phase tells you how much faster you're going to be able to go in the next phase. So the longer one phase, the more it takes in the next phase. It's a statistical anomaly that we've known since 1987. It tends to hold true. So think of it this way, break it this way. Days in a full recovery would be based on a times 10 multiplier, which kind of makes sense. You think of the initial response. So the search and rescue teams get in, they save lives, they mitigate any of the disaster. That makes it safe for the utility companies, the Department of Transportation, sewage treating, all of that to get restored. Once you can get back, move people back in, now they've got to go through reconstruction. They've got to get the insurance companies in. They build their homes back. They build their businesses back. They put in their small business loan work in. And then they can get back to actually recovering, bettering, becoming more resilient. So you can see the trick is that if you can get the first phase done faster, or any of the other factors, that makes the rest of it go faster and shorter. So let's just see about how much faster. If you take 1 day off of that initial response phase at the very beginning, when the search and rescue teams, if they can do their jobs faster, then it is 3 years shorter for full economic recovery. So if you can take a ground robot like this one, use this to search in the rubble and find survivors a day earlier, just 1 day earlier, to find the state and what is the composition of that rubble and that structural elements 1 day earlier, 3 years off of economic recovery. Let's look at something like Hurricane Sandy, where all the utilities are down. That's the restoration phase. If you can use, the utilities can use something like a UAV, which we're experimenting with now, to restore power one day earlier, it's not 3 years, but it's 3 months. And it certainly impacts what's going on, the quality of life and economic recovery. And think of that same UAV. If the insurance companies, I as an individual, this is great for economic recovery for the entire country, but what about economic recovery for me? Well, insurance companies are saying that they can service a claim. If they can service a claim 1 day faster, 6 months quicker on getting their claims, the repairs and everything done. And they're looking at using these UAVs. So it's a game changer. It's a game changer. So that's what we're looking at. It's a game changer because robots can make disasters go away faster. Right. So in the disaster game, you're talking about how to keep score. We've talked about, you've met a couple of the players. They're small, they're light, they're inexpensive. I didn't bring any of the underwater, the water-based ones, but you saw a picture of that. So what are the rules? Because rules are important. They make the difference in whether there's something that's an innovation and could be used in something that's actually used. And that's really important. So some rules that we've done in our country have been fantastic, like the way that we attract the top talent from all over the world. This Dragon Runner was developed by Hagen Schmidt, a professor at Carnegie Mellon with a name like Hagen Schmidt. Let's all guess, yes, he's German. Okay, we take the best people, we train them, they do great technology, we commercialize it. So that's a great story there. Let's think about other stories though. Look at this one. This was one of the very first of the small UAVs. Now there's close to 250 manufacturers of UAVs worldwide. Of course, the largest manufacturer is Chinese. This was originally developed in Canada. Is Canada more innovative than the United States? No. The regulations are more favorable for small UAV development pretty much any place in the world than the United States. And when I heard this morning that 11% of the gross national product is being associated with rule compliance, I'm thinking that's not even counting the times that the rules are keeping us and chasing our research and innovation away from there. So that's a problem. But it's not just rules. What about the rules of things like, the FEMA teams, our 28 FEMA teams, urban search and rescue teams, they don't have any of these technologies, even though these were used at 9/11 quite well, thank you very much. These were used starting with Hurricane Katrina, 2005. 10 years later, still don't have them. Why not? Because no standards. If they're not on standards, they're not going to be put on the government purchase list. If they're not on the federal purchase list and they're not on the state purchase list, you're not going to buy it if you. Okay, so it's a cycle. It's an important one. And what concerns me, it's not just that, it's the idea that in Europe, they're spending 5 times as much just on disaster robots, just on that segment of the market. And there are a dozen other major initiatives that Europe is funding to keep their innovation and their translational research that's going to create this next set of products there. So robotics is game-changing for disasters, and we need you and the Council on Competitiveness to keep the United States in the game.